Water is life. And in South Africa, water is scarce. The solution? Underground water. Waste. We can help. Drilling for underground water is expensive. How can you be sure that you will find underground water? Can you afford to guess? Waste, a South African company dedicated to becoming a leading supplier in the industry of finding underground water. Established in 2001, Waste addresses the growing need for more scientific and modern methods to find underground water. It provides accurate results to drillers, developers, homeowners, farmers and municipalities. We help clients to evaluate potential drilling locations on the property without the expense of drilling test holes. We provide estimates of depth and yield on the identified and surveyed locations. We help the client to make an informed choice on the optimal drilling location, reducing the risk of a dry hole. Through years of experience and improving technology, Waste has developed the capability to accurately and reliably predict the best sites for drilling boreholes. We use a combination of preliminary and on-site research that is done via computer satellite, global information systems, GPS and geological information predictions. The latest state-of-the-art geophysical technology is used to identify borehole sites and is based on scientific principles that has been proven to consistently provide accurate results. For scientific borehole siting, we use 4 different methods, each with its own siting characteristics. Magnetic method. With this method, a change in the normal magnetic fields of the Earth is perceived, which can be used for picking up concealed geological contacts such as dolerite dikes. The use of this method with the necessary interpretive knowledge of the data can result in successful boreholes in a correct geological area. Electromagnetic method. This method is related to the electrical resistivity method, based on a difference in the electromagnetic conducting abilities of rock formations. These inductive methods are used increasingly in groundwater explorations, with the advantage of the speed with which these surveys can be carried out. The area of application of the electromagnetic method is similar to the electrical resistivity method. In this method, the difference in the passing of an electrical current through different rock formations is measured. In this way, a difference in the resistance of rock types can be identified, which can be correlated with possible bearing zones. Due to the fact that water conductivity is the most important cause of electrical conductivity in rock formations, this method is directly related to groundwater occurrences. A further benefit of this method is that the resistivity is not only laterally detected over an area, but also in depth by a specific point. The electroseismic method is based on a phenomenon of electric seismic signals that are generated through a relative movement of water against a subsurface rock matrix. This movement of the groundwater is established through a seismic wave. By proper processing and interpretation of electrokinetic signals, the presence of groundwater, its estimate depth and probable geometry can be determined. What sets this technology apart from conventional geophysical methods is the fact that the presence of water is responsible for the generation of electroseismic signals.
Well, ESS is an electroseismic piece of equipment that's designed to find groundwater directly. It's one of two methods currently available that can do that. It doesn't work using geological structures that are usually associated with finding groundwater, but it actually makes use of the physical groundwater itself to generate the signals that we record and analyze to determine what's going on under the ground.
The ESS technology is an effective tool for mapping of groundwater resources, the development of these resources, and the management of current and future groundwater supplies.
It's been around for quite a long time. It was originally discovered around about 1952 by guys doing seismic work, and they've noticed a small squiggly little signal in the beginning of their records, and they couldn't understand what it was. And around about 1965, a scientist went in and actually analyzed those signals, and he found that it had some sort of direct relation to the geologies or aquifers, and the science was basically born.
It is a means to reduce the cost associated with development of groundwater supply schemes and is geared towards providing valuable and practical, usable information concerning groundwater structures and other geological formations.
When we do analysis of it, you can do it one of three ways. 1D traces, basically looking at a single point, what's happening underneath the ground. What I tend to do is use a 2D contour plot, and what that does is basically a whole bunch of information from points in a line put next to each other on a nice little picture, and then you can actually start seeing stuff like patterns like aquifer extent. You can start tracing stuff like how far does it go, where on those aquifers is it most permeable. When I say permeable, I mean where does the water flow the easiest, being that that's probably where you would drill. And the third option is a 3D analysis, which is mainly used for mapping. So what we would do is take a site like this, and what we would do is do a grid survey and then show all those points in conjunction with each other from top down and from the side. And the point of that is to try to understand where the aquifers are, not necessarily for drilling purposes, just what's the best location to start looking for a good drill site.
The ESS can obtain valuable information of geohydrological nature, which was only available by expensive drilling and pump testing techniques in the past.
So as far as you're concerned, you can tell how deep different aquifers are, so you can work out which ones to go through to get to the best supply.
Oh, absolutely, yes. We can tell exact depths. It's very, very good at that. My personal experience, I've had as many as 5 aquifers at different depths that we've been able to drill into.
The ATS GeoSuite technology is at the cutting edge of geohydrological and geophysical development all around the world, and it brings an extra dimension of information to geophysics as never seen before, making groundwater project management more effective and affordable.
South Africa is a very good testing spot for a system like this.
Yes, we've got incredibly stressed aquifers, so groundwater is a big issue. In fact, all water, fresh potable water, is a big issue in South Africa. So as a start, as a breeding ground, a testing ground for the technology, I think we couldn't have had a better start.
What is the percentage of success?
On the electroseismics alone, my personal success rate is 85% of usable water. When I say usable water, that's 3 liters per second or more. But if you combine it with other geophysical equipment, such as magnometers, cell potential, resistivity, temp sounding, whatnot, that is relative to the area that you're working in, you can push that up considerably. I mean, I've got a couple of consultants that are claiming to be at 98%. That means that they miss a borehole once in a blue moon.
This unique approach to groundwater investigation and development brings a whole new dimension to groundwater geophysics. The ability to map groundwater by directly detecting its presence greatly improves on time and cost associated with groundwater development and investigation projects.